Hello, I'm Paul Beckwith. I'm with the University of Ottawa Laboratory for Paleoclimatology. And I've got some helpers here. And so what I'm going to do is explain exactly what I think is going to happen in the Arctic as we move forward. As we go to a blue ocean event, how will that affect the wind patterns in the Arctic? How will that affect the water circulation? The water both exiting and leaving the Arctic Ocean. How will it affect the water temperatures, the air temperatures in the surrounding land? How quickly will it impact the frozen permafrost that's all on the continents bordering the Arctic? How quickly will it warm up the water, especially over the shallow continental shelves all the way around the Arctic? And when we have a blue ocean event, presumably the first year, at the end of the melt season, so come September, maybe for a couple of weeks or the full month of September, there'll be no sea ice, and then the ice will start forming. And within a year or two, I think the ice will go in say August, September, October, within a few years. Within maybe a few more years after that, it'll be gone for July, August, September, October, November. And, as the feedbacks kick in, it will head to being open ocean for the entire year. So, and then we'll have transitioned into a much different world, a much different climate system. So basically, right now what we have is we have this ice cap. We have the sea ice in the Arctic Ocean. Of course, we have the big area of Greenland with the glaciers, and it's white. Now we know that and then we have the snow cover on the surrounding land masses, also snow falling on the ice, making the ice whiter and more reflective for that period of time. And we know that the overall Arctic is getting darker. So the reflectance of the overall Arctic used to be about 52% or so on an annual average basis a few decades ago, and now it's dropped to 48% reflectivity. Because it's getting darker, in the summers, there's more of the light is absorbed into the materials, into the darker materials, less is reflected back up to space. So that more energy that is being absorbed is causing heating of the Arctic from the sun, and of course that lowers that causes Arctic temperature amplification, greatly heating the Arctic much faster than the equator, and therefore lowering the temperature gradient to the equator. Therefore the jet streams are slowing down and becoming wavier, and the ridges of the jet stream are even extending up into the far Arctic. Even in the middle of the winter, when these ridges do that, it brings up temperatures above zero in the middle of the winter. Now the key thing is the latent heat effect, the phase change effect. As long as you've got ice in the Arctic Ocean, and the ice is being, in the summers, the heat is going into melting that ice. The temperature stays at the freezing point, essentially, which is not 0 degrees for salty water. It's minus 1.8 degrees. So the temperature is maintained there until the ice is gone, and then the temperature will greatly increase. All of that energy that's melting that mass of ice, you can calculate how much it will raise the temperature of the water, and the amount of energy that melts a kilogram of ice at 0 degrees Celsius, now it heats that water at 0 degrees Celsius, it heats it to about 70 degrees Celsius. So there's a huge effect here. When there's no ice, the temperature in the Arctic is going to skyrocket. So how is that going to affect the ocean circulation patterns in the Arctic and the air circulation patterns in the Arctic? and how will that affect the surrounding continents, and what other feedbacks will kick into place. So in some previous videos, I talked about a new phenomena called the Arctic monsoon. The basic idea is that in the summer, when, especially with very, very little snow cover in the spring, okay, the continents are much darker, they're going to absorb a lot of solar radiation and they're going to heat up. And we're seeing very, very hot temperatures, above 30 degrees Celsius, especially up in Scandinavia, north of the Arctic Circle. Okay, up in Finland, etc. Very, very high latitudes. There's 70 degrees north right here. So even north of this latitude line, we're seeing 30-degree temperature Celsius and higher. And basically what happens is, because of this heating of the land, there's a lot of hot air rises. The air rises above this hot land. Creates a low pressure area at the surface. It draws in water from the ocean. And that water, because there's no ice there anymore, that water, that air that's drawn in from the ocean has higher levels of water vapor. Hotter air could hold more water vapor. So that comes ashore, that's drawn ashore, it has convective uplift, and it condenses into droplets, the air vapor, creating clouds, and that energy is released and it fuels these torrential rain events. So that would be the monsoon on condition. And then in the winter, the land cools down more than the ocean. So now the land is colder, the oceans are warmer than the land, the air rises over the oceans, therefore creates a low pressure at the surface, and it draws air from the land over to the ocean. So this is the monsoon. This is the monsoon off, basically. So what the problem is okay, so right now the circulation in the Arctic, we have the Beaufort Gyre. The ice keeps things very, very cool, right? The white surface reflects sunlight. It's very, very cool at the surface, even in the summer. Okay, and the land will be warming up, but the oceans and the air over the sea ice stays cold. So what happens is there's a cold pool of air over here. Okay, the air is rising over the land, low pressure over the land, so it draws air from the ocean over to the land, but we've got this sea ice cover, and it's very cold still, so there's not much water vapor in the air. There'll be some snow along the coastlines, but there's not much water vapor because we've got cold air over the sea ice. So what happens is, okay, the air is drawn out. It deflects to the right in the northern hemisphere because of the Coriolis force. So the air is drawn out here, deflects to the right. So it sets up a wind pattern here. Okay, it sets up a clockwise wind pattern, and that moves the sea ice in a clockwise fashion. And we call that the Beaufort Gyre. Okay, some of it breaks off here, and we get this transpolar drift out this way. Okay, so we get the clockwise Beaufort Gyre, transpolar drift here, and that can contribute to the export of sea ice out of the Arctic through the Fram Strait, for example. Okay, so that's the sort of pattern that we have and that we're used to. Now, what happens when there's no sea ice all of a sudden? Okay, when there's no sea ice, then the surface temperatures of the Arctic Ocean water will warm and warm and warm, and what will happen is the land will also warm, and in the middle of the summer the land will be hotter than the water, so the air will rise over the land all around the body of water, creating low pressure at the surface, and that will suck air, marine air, onshore. And it deflects to the right in the northern hemisphere, But the difference is now we've got the air, the marine air, the air being drawn from the ocean will have a lot of water vapor because there's no sea ice. So there's evaporation of the seawater, and there's water vapor coming ashore. Then it has this convective lifting. That water vapor then condenses into droplets, forms the clouds, and it will lead to torrential rains along the border surrounding the Arctic. Now this is a huge problem because there's no better way to thaw out frozen permafrost than by having water falling on it. Think of what gets rid of snow in the spring, okay? It's not just generally temperature increasing and all the snow melting. What happens is temperature growth goes above zero, then there's rainfall. And the rainfall, of course, the rain temperature is above zero. You know, it melts through and cuts in and it takes out the snow and destroys all of the snow very quickly. So when we have all of these torrential rain events around the coastline of the Arctic, that water will go seep into the ground. It'll thaw out the organic material that is frozen in the tundra and permafrost around the Arctic Circle. And that is bad news because that water thawing out the permafrost and tundra on the land very, very quickly will expose the organic material to decomposition, and in the presence of oxygen, CO2 is produced, and in the absence of oxygen, so in the small lakes and things around, and rivers, if you're under the water and there's an absence of oxygen, then you'll get methane produced. So these torrential rains from this Arctic monsoon behavior will then kick the carbon feedbacks into high gear. Not only that, but the warming ocean, especially on the continental shelves, it's less than 50 or 100 meters deep. It's thawing the sediments on the seafloor, and that exposes the methane that exposes the permafrost that's on the seafloor and the methane clathrates that are on the seafloor to warming and ebullition, bubbles coming up, and large release of methane. Okay, so these are all big problems. Now, also because the Arctic is now so warm, the jet streams are much, much weaker. So at lower latitudes, okay, where most people live, we're going to see an enhancement of these situations where we get droughts for long periods of time. For example, I'll give the example of Ottawa. This is happening around the world, but last July we had huge amounts of rain. We normally get about 70 or 80 millimeters of rain. We had 3 times that. We had over 200 millimeters of rain for the month of July. This year, for the beginning, we had basically no rain for months and months. We had a severe drought, and then it's like a switch turned, and now we're getting more and more rain. But last year we had huge rain, so this is why you get weather whiplashing. You go from one state to the other state. So lower latitudes, there's going to be huge changes in the precipitation pattern, and this makes it very difficult to grow food. So we know that as a result of these heat waves and so on in the northern hemisphere that have been going on this summer, we're going to probably have global food shortages. So this is a huge problem. At least we're going to have price spikes. So anyway, thank you for listening.